Hi everybody, this is Mrs. John with a lesson for Year 12 Physics. This is Atomic and Nuclear Physics, and I'm answering a question on radioactive emissions. Now the question reads, the people who work with radioactive material have to be very careful not to be exposed to radiation. They wear special badges that contain photographic film that is exposed if any radiation gets through to it. When the film is developed, darkening of the negative indicates exposure to radiation. The badge is light proof, and two of the three sections of the film are covered as shown here. So this is a light proof badge, and it's divided into three sections. The first one is not covered at all. The middle one is covered with paper, and the last one is covered with aluminium foil. So that's how this is. So question one is explain why these badges need to be worn outside any clothing. And the reason is if the badge is worn inside the clothing, cloth can stop alpha radiation. So you will not know if you've been affected by alpha rays. Okay, and then the next one, explain why the badge must be light proof, because it's made of photographic film. However, you know how photographic film, when exposed to light, is affected, but these have to be light proof because we are trying to find out if the person who's wearing the badge has been affected to radioactive emissions, which could be alpha particles, beta particles, or gamma rays. So you don't want them affected by light because you wouldn't know which one it is. Then, for each of the following negatives, explain whether it's possible to identify the emissions present. So I'll just explain. So I've drawn the following diagrams. So in the first one, the part that's not covered by paper or by aluminium foil has been affected. So this negative has been darkened over here. So if only this part's affected, it will have to be alpha particles, because alpha particles can be stopped by paper. It cannot go through aluminium foil. So the answer to the first one is alpha particles. Okay, now in the second one, two of the three parts have been affected, and you will see that the uncovered part as well as the part covered by paper have been affected. The radiation hasn't been able to penetrate aluminium foil. So what does this tell us? So because the radiation has gone through paper and not through foil, it's definitely beta particles. But because this part has also been affected, the part that is not covered at all, then there is a chance that there could have been alpha particles as well. Okay, so beta and perhaps alpha as well is the answer for this. So gone through paper will have to be beta, and the other part could be alpha. And the last one, the whole thing has been affected. So because the radiation has penetrated through foil, then that will have to be gamma rays, because gamma rays can go through paper, it can go through foil. Okay, but because it's gone through paper, we don't know if with the gamma rays there were also beta particles. So there could have been beta particles, but we don't know. There's no way of us finding out. And because the uncovered part has also been affected, there could have been alpha particles. How do we know? We don't know. So definitely gamma rays, but with the possibility of beta particles as well as alpha. Why? Simply because the other two parts have also been darkened. I hope that made sense, and that's the answer. Bye for now.